Let us consider how to find the dipole moment of a given system of charges. Okay, generally dipole stands for only two charges. Okay, one is plus charge, another is negative charge, and they must be having same magnitude and they are separated by a very small distance. Okay, in that case it is very simple formula, the dipole moment equals to charge into distance between them. Okay, but if the system is some number of charges that are existing, for example in the system there are some 4 5 charges or any number of charges existing, and what is the dipole moment of that system, suppose they are asking you, then how to find that, let us discuss. Okay, so let us consider the system of charges here. Okay, say this is charge q1 at a distance r1 from the origin, and this is the charge q2 at a distance r2 from the same origin, and so on. There are n number of charges. The nth charge is here qn, and the distance from the origin, the displaced like position vector, is rn. Now the dipole moment of this system of charges is given by, it's very simple, the dipole moment p vector equals to summation over I runs from 1 to n, it is qi into ri vector. If you expand this, you will get q1 into r1 vector plus q2 into r2 vector, and so on, qn into rn vector. Okay, so remember, when you are applying this formula, you have to take the charges with their sign and also position vector including their sign. I mean, if some of the position vectors, one of the position vectors may become negative. Okay, so you should consider the negative as it is, right? Let us consider one example. That example, let us have the three charges, just three charges it is, and they are placed at the three vertices of an equilateral triangle of side A. Okay, and let this be the origin. At the origin, say q is placed, at this point another q, and here minus 2q is placed. And what is the dipole moment of this system of charges? Very simple. First of all, whenever you are finding the dipole moment, you first you should check the monopole moment, whether it is 0 or not. Okay, monopole moment means actually sum of the charges. Okay, it is coming 0. So by giving this equation 0, we can understand if the monopole moment is 0, then the dipole moment is independent of the origin. That means wherever you consider the origin, the dipole moment will be independent of the origin. It will give the same value. Okay, so let us consider here the origin. Then this is your y-axis and this is going to be your x-axis. Okay, then the initial, like first charge, will have the position vector 0 I cap plus 0 j cap. The second charge will have r2 vector equals to a I cap plus 0 j cap, while the third charge r3 is going to be this one. From the resolution, it is a by 2, and this is going to be root 3 by 2a. Okay, because this is 60 degrees, it's an equilateral triangle, so opposite is going to be sine function. Sine 60 is root 3 by 2. So we can say a by 2 I cap plus root 3 by 2 a j cap. These are the position vectors of three charges. Now in the formula you have to substitute, that is the dipole moment of the system of charges equals to, you know, q1, that is capital Q into r1, plus q2, this is q2, okay, q2 into r2, that is a I cap plus 0 j cap, plus q3, that is minus 2q, should take the sign also, minus 2q into a by 2 I cap plus root 3 by 2 a j cap. Okay, so if you add all this, you will get the dipole moment of the system. Here anyway this will be 0, and it is q a I cap, and it is 2 2's are cancelled, so minus q a I cap. Okay, and it will be minus root 3 q a j cap. Okay, so yeah, so q a I cap, it will be cancelled, then dipole moment is going to be, it is minus root 3 q a j cap. This is the dipole moment of the given system of charges. I hope you got the clarity on this. And the formula is very simple. The formula I am giving one more time. The dipole moment of system of charges equals to, qy into ri vector plus, q1 into r1 vector plus q2 into r2 vector and so on, qn into rn vector. This is the general formula to find the dipole moment of any system of charges. Okay, thank you.